All right, here we have a short problem where we're told we have a 12-volt automotive battery and it's charged with a constant current of 1.5 amps for 3 hours. Determine the work done on the battery. So here's our battery, and we have some current coming into it across some voltage. So we have some amperage, I'll call it I, across some voltage, call it V. And we're trying to find the amount of work being done here. So the power that's going into the battery, by the way, I'm going to draw a dashed line around the battery to indicate that that's our system of interest. And if I want to find the power acting on the battery, this is electrical power. The electrical power is going to be the voltage times the amperage. Right? So that would be, in this case, 12 volts times 1.5 amps. And let's see, what do you get when you multiply that out? That comes out to be, what is that, 18 watts. That's of power. Now, if I want to get the actual amount of work done on the battery, I need to integrate that over time. So the work done on the battery would be the integral of the power on the battery over the time, as we go from some initial time to some final time. Now in this case, the voltage and the amperage are constant. So the power on the battery is just a constant. So that makes it easy. We can pull that outside the integral. Again, you can only do this if the power is a constant. If the power varied with time, then you'd have to actually do the integration. But here, we can pull the power outside because it's a constant. This integral is easy. That's just going to be final time minus the initial time, which in this case is 3 hours. So our work would be the power on the battery times the delta T here. This we just calculated was 18 watts. The time is 3 hours. Now we have to be a little careful with units here because watts is like a joule per second. So we need to convert the hours over to seconds. So I'm going to multiply this by, 3,600 seconds per hour. So I can make sure I do the conversion properly. And when you plug the numbers in, this will come out to be 0.2 kilojoules of work on the battery. Okay, so just a few things to keep in mind for this simple example. First of all, electrical power is the voltage times the amperage. Secondly, if you're going to find the work done, you have to integrate the power over time. Here the power is a constant, so I can pull it outside the integral like I did here. And then the last thing you have to be careful of is we're given the time in hours. Watts are like joules per second, so you have to do a unit conversion here to make sure that the units work out. And so that's how we arrived at this answer here when you plug in the numbers. Okay, we'll end the example there.